Hello, my name is John Baumgardner. I'm currently at the Faith and Science Conference in St. George, Utah in July of 2017. I was one of the presenters here. My field is geophysics, and for almost 40 years I've been working on the problem of the mechanisms behind the Genesis flood. And it was close to 40 years ago that I realized that plate tectonics, very rapid plate tectonics, had to have played a major role in the transformation of the earth that took place during that short period of time of approximately 1 year that the Bible gives for the duration of the flood. And so if we understand the fossils that we find in the rocks to be the result of this global catastrophe, that implies that a staggering amount of geological change unfolded during that brief period of more like a few months than the full year. So the question almost automatically arises as what sort of mechanism could cause such a vast amount of geologic change in such a short period of time. And as I just said, I was for about 40 years I've been convinced that plate tectonics, rapid plate tectonics, is a large part of the answer to that issue. So here at the meeting I presented several aspects of that. One of the aspects I dealt with was how can rocks deform so quickly? How could tectonic plates sink into the earth such that all the surface of the earth, certainly all the oceanic surface, got recycled into the earth's interior in just a few months' time? And over the last 40 years I've worked very hard on that. Actually, laboratory experiments show that rocks can weaken dramatically when under stress. And so I've spent a lot of time developing computer models for that, and have demonstrated that taking published experimental data on how rocks deform, that type of catastrophe will happen, can happen, and will happen under the kind of circumstances that we believe occurred in the flood. So I believe, I don't have time to go into detail, but I believe the mechanism for rapid plate tectonics, plate tectonics happening about 1 billion times faster than is occurring today, where rocks today the rocks are moving across the face of the earth approximately 2 inches or so per year. During the flood, they would be moving at about 5 miles an hour, or approximately 2 meters per second during that cataclysm. So as far as the mechanism, I believe that is now understood. And then there are still other major questions. And one I addressed here at the meeting was, how do we account for all these sediment layers that are certainly in this area around us, show the layer cake structure, flat layers extending for hundreds to thousands of miles in both directions, with hardly any erosional channeling between the layers. What kind of process could result in sediment deposition of this sort? A style radically different from what's going on the continents today, where we have extreme channeling by rivers, localized erosion, localized deposition, not this kind of deposition that produces these flat-lying layers over such vast areas. And so my modeling on that, one aspect of rapid plate tectonics is the generation of very large tsunamis. And assuming, just taking for granted that the plates behaved during the flood as they do today, specifically that they lock. The overriding plate tends to lock with the subducting plate until the stress builds up so that that fault becomes unlocked and there's rapid slip. And if the slip is very, very significant at all, you get a tsunami generated. So I've been doing calculations to look at the consequences of these large tsunamis. And a surprising thing that I find is that the tsunamis, at least initially, place more water on the continents than can drain off by gravity, so until an equilibrium is reached. And so I find that these tsunamis just naturally place up to thousands of feet of water over the continents just by repeatedly placing their water on the continents. And then the Earth's rotation with this, what's known as the Coriolis force, tends to organize the water flow over the continents and provide the large-scale coherence of currents that result in the deposition of these large-scale, laterally horizontal, horizontal scale sediment layers. And also these tsunamis cause extreme erosion, especially along the continental margins, and generate the volumes of sediment that we find in the sediment record. And this water is turbulent. This water that's driven by the tsunamis is highly turbulent, able to suspend large amounts of sediment, and these currents that are flowing over the continents transport the sediment and deposit it. So I believe we now have a very straightforward mechanism, easy to understand, as to how this sediment record that we see, for example, exposed in the walls of the Grand Canyon, and in the layers up above the Grand Canyon where St. George is located, how these layers could be produced in a short period of time, within a few months' time during the flood. So I was excited about being able to present these results, and I'm encouraged that researchers like myself are providing some good answers to these big questions relating to the Genesis flood.